This last video on nomenclature from chapter 2, to a lesser extent, will you have to worry about naming of organic compounds, but in general, when we talk about organic nomenclature, it's the study of compounds that contain carbon atoms. So this will be what we plug in here. So the study of carbon compounds. So alkanes, these are described as the simplest hydrocarbons when we have carbon and hydrogen only, and we have all single bonds. So any carbon-hydrogen connection will be only a single bond every time we form a molecule. But when we have carbon-carbon bonds, those are also going to only be single bonds in an alkane. So when we name these compounds, the number of carbons corresponds to the first part of the name. So if we have one carbon, we call that a meth group. So we have meth, and then the ending ane comes from the fact that it only has single bonds and it's an alkane. So a one carbon alkane is methane. A two carbon would be ethane, like we see here. And then a three carbon chain would be a propane molecule. Again, all single bonds, and we would just remember that one carbon's meth, two is eth, three is prop, four would be bute for butane, right? If we had a four carbon chain. And we can go up higher and higher. Then when we add a different functional group, like an alcohol here, we change the ending to indicate that there's an OH or a hydroxyl functional group, and these become alcohols. So we still have a single carbon, so it has that meth prefix, methane. Instead of methane ending in ANE, we change the E to an OL. So the same thing happens here when we have a two carbon alcohol. So we have ethane and then OL for the hydroxyl group. And then here, notice there's what's called a locant here, or a location for where that hydroxyl group is, because we have on the end here a one propanol, so for three carbons with the OL hydroxyl ending. Or if we had the OH group here, this would be called a two propanol. So let's see if we could figure out the name for an alcohol in this next example here, and the molecular formula of butane first. So butane is indicating four carbons in a row. So we could write that out like this. And we know that every carbon always has four bonds. So we would fill in all of these spaces here with hydrogens after we link all four carbons together in a four carbon chain. So now we can count and we can see that there are four carbons, so C4, and then 3, 6, 7, 8, 9, 10 hydrogens in our compound here. So we have C4H10 is our molecular formula for butane. And in part B here, we want to know what would the alcohol be if we change one of these hydrogens to an OH group here. We would know that the name would start with butan again, and then end with OL. So we have butanol. So this is everything from chapter 2, and we'll continue with chapter 3.